to the sixth part on arithmetic sequences. Children, today I am explaining some important questions for your exam. Look at the question. Prove that the arithmetic sequence with first term 1 by 3 and common difference 1 by 6 contains all natural numbers. We have to prove the arithmetic sequence with first term 1 by 3 and common difference 1 by 6 contains all natural numbers. Okay, see how I am going to do the problem. First of all, we can write f is equal to 1 by 3. But since the denominator is 6, I am writing the first term also with denominator 6. So 1 by 3 is same as 2 by 6. We are given common difference is equal to 1 by 6. Now let us write the nth term. You know the formula for nth term as dn plus f minus d. That is equal to, our d value is 1 by 6. So 1 by 6 n plus f value 2 by 6 minus 1 by 6. So you get n by 6 plus 1 by 6. Or you can write it as n plus 1 by 6. You get a fraction. Now we have to prove this arithmetic sequence contain all natural numbers. Now when do you get the first natural number? You know the natural numbers are 1, 2, 3, etc. Now when n is equal to 5, you get the first natural number 6 by 6 equal to 1. Is it clear? So let me substitute. When n is equal to 5, we get 5 plus 1 by 6 is equal to 6 by 6, 1. Now to get the second natural number, n should be given the value 11. So that 11 plus 1, 12. 12 by 6 is equal to 2. When n is equal to 11, we get 11 plus 1 by 6, which is 12 by 6 equal to 2. In a similar way, we get all natural numbers by giving different values for n. Clear? Come to the next question, a similar question. Prove that the arithmetic sequence with first term 1 by 3 and common difference 2 by 3 contains all odd numbers but no even numbers. Here again we write the nth term first of all. We are given f is equal to 1 by 3 and d is equal to 2 by 3. Let us write the nth term. Nth term is equal to dn plus f minus d. Substitute the values. D value 2 by 3 n plus f value 1 by 3 minus d value 2 by 3. This is equal to 2n by 3 plus, from 1 by 3 you are subtracting negative 2 by 3. So you get minus 1 by 3. Or otherwise we can write it as 2n minus 1 whole thing divided by 3. This gives you the nth term. Now what is our question? We have to prove this arithmetic sequence contains only odd numbers but no even numbers. Now how do you prove it? Come to the nth term. See here children, 2n minus 1. We have studied already. Nth natural number is n. Okay. Nth even number is 2n. 2n minus 1 gives you the nth odd number. Do you understand? So here you are getting an odd number divided by an odd number. Now what do you know? An odd number divided by an odd number will be always odd. 2n minus 1 is the general form of the nth odd number. So we can write this is an odd number. Okay, our numerator is always going to be an odd number. So here you are getting an odd number divided by 3. An odd number divided by an odd number will be always odd. You will never get an even number in this arithmetic sequence. This is how we prove it. Let us discuss one more question of the same type. Okay. Write the whole numbers in the arithmetic sequence 11 by 8, 14 by 8, etc. Do they form an AS? So, use our same idea. That is, we have to write the nth term. Okay. Our first term, f is equal to 11 by 8. And what is our common difference? Common difference is second term minus first term. Since the denominators are the same, write the same denominator. 14 minus 11 gives you 3. Now let us write the nth term. We know nth term is equal to dn plus f minus d. That is equal to 3 by 8 n plus 11 by 8 minus 3 by 8. That is equal to 3n by 8 plus 11 minus 3. So you get 8. 8 by 8. Clear? Otherwise, you can write it as 3n by 8 plus 8 by 8 gives you 1. Now what is our question? Write the whole numbers in the arithmetic sequence. So first of all, we should write the whole numbers of this arithmetic sequence. Now we know 1 is a whole number and 3n by 8 becomes a whole number when n is given the multiples of 8. When n takes the value 8, 16, 24, etc., you get the whole numbers. When n is equal to 8, we get 3 into 8 by 8 plus 1. So 8 and 8 cancels. You get 3 plus 1 is equal to 4. Do you understand? Similarly, when n is equal to 16, that is the next multiple of 8. What do you get? We get 3 into 16 by 8 plus 1. That is equal to 6 plus 1, 7. Is it clear? Now, when you substitute n is equal to 24, you get the next answer, that is 3 into 24 by 8. So you will get 9 plus 1, which is equal to 10. Is it clear? Now come to the second part of the question. First part is write the whole numbers. So let me write the whole numbers first. The whole numbers here are, you are getting 4, 7, 10, etc. Isn't it? Come to the second part of the question. Do they form an AS? Do they form an AS 4, 7, 10, etc.? Yes, of course. Because the common difference here is 3. So we can say, yes, the whole numbers form an arithmetic sequence with common difference 3. Is it clear, children? So today we have discussed 3 questions of the same type.